Well, hello everybody. I'm Dr. Randall Milstein. I'm a faculty member here at Oregon State University in the College of Science Physics Department, as well as the College of Earth, Ocean, and Atmospheric Sciences and the University Honors College. I am also the astronomer in residence for the Oregon NASA Space Grant Consortium. I've been asked tonight to come and answer some questions that were submitted about astronomy. What is space and how big is space? Well, that's another very interesting question. A lot of times people think of space as nothing, but that is not a concept acceptable in science. There is no such thing as absolutely nothing, because even in the void of space, there may not be a planet there or a star there, but in the meantime, you have energy going through, you have light going through, you have unlimited potential that's in that open area. Now, it's confusing because it has to do with the idea of nothing. For theologians and philosophers, nothing means non-being, but no such thing exists in science. There is no absolute nothing. Nothing is just as real as something. And I think the question went on to say, how big is space? Well, right now, we don't have a real answer for that. Our idea of what space's size is limited to what's called the cosmic light horizon. That's a distance at which light has traveled to reach Earth, and we can observe it. And that look-back time, that travel time for that light, is right now 13.8 billion years. Now, it's very interesting because we're seeing light at 13.8 billion years ago, so it's traveled that long to get to us, and we see that object looking back in time. But that object is moved 13.8 billion years farther away. And so right now, we're just limited to the light that we can see by the cosmic light horizon, and that's referred to as the observable universe. As we get more powerful equipment, hopefully the new James Webb Telescope very shortly, we'll be able to see farther back, and we will move that cosmic light horizon farther back in time and be able to give a longer distance to how big the universe might be as it expands outward. Oh, here's a good one. Are there aliens out there? Are we alone? Well, we don't know. That's the honest answer. There's a couple ways to look at this. If we think of Earth and how life formed here, and if the laws of physics as we know them and the laws of chemistry are universal, which we know them to be so far, the fact that life could form here under certain conditions, in our case, water, and a constant flow of energy from our sun that's regulated by our atmosphere, and certain chemistry on the planet, if that exists somewhere else, there's no reason to think that that should not be the same ingredients and conditions that could cause life somewhere else. Now, that life might not be life that we recognize, and that's very important. Life as we find it somewhere else might not be life as we know it here. We have very many extremophiles that live here on Earth. We actually have one bacteria in the subsurface of our planet that actually eats uranium and expels as waste crystals. We have snottites who live in complete and total darkness in caves and use hydrogen sulfide as a food source. Again, that's the second most poison gas to human beings. So we could go to a different world, and that alien life might be something like that, a bacteria, rather than a sentient being. I personally think that the most frightening thing we might find if we went to a different world would be an alien life form that looks just like us. That would send a lot of people on this planet into quite a tizzy, I think. Would shatter a lot of their preconceived notions. What are some common sci-fi stereotypes that aren't real in actual space? Wow. There is a lot of science fiction out there that's very good. Most of it's character-based. and tells us some really interesting stories, but there's also some very exciting adventures out there. And a lot of science fiction is heavily militarized, so our spaceships have to have certain characteristics, like really cool sounds that come out when missiles are fired and things. Common mistakes are that you can't see lasers in space. There isn't anything to reflect the light in the vacuum of space. That vacuum also makes sound not happen. You can't hear in space. There is no sound. The famous movie Aliens poster used to say, "In space, no one can hear you scream." That's so. You can't hear explosions either. When you see the explosions in a sci-fi movie, there's flames everywhere. That doesn't happen either. There's no oxidizer in space that would make that flame burn. And my favorite one of all, and I use this with students quite frequently, is we love to see Star Wars when X-Wing and Y-Wing and TIE fighters chase each other through the void of space, and they bank and roll, and you go in to make the trench run on the Death Star, and everybody's zooming and zipping around. You can't do that in space. It's a vacuum. Here on Earth, when we fly fighter aircraft and do that, we have air resistance to push against the ailerons and the other planar surfaces that allow us to bank and roll. Those don't exist in space. All we have in space is thrusters, and they allow us to go forward and backwards, up and down, left and right, and you can do it at quarter, half, 3/4, and full turns, and that's it. A space battle would look more like a video game from the 1980s when things move up and down and go back and forth, but no banking and rolling. It makes for wonderful entertainment, and sure, I love watching it too, and it's exciting and fun, but my science mind tells me to suspend my disbelief and just enjoy the show. If this is something that interests you and finding answers to these type of questions, I would really recommend that you take Physics 104, which is descriptive astronomy. The other class I teach is observational astronomy, where we do a little more in depth about how we view the solar system and the universe. Physics department also has a 200 sequence of classes that are distinctly solar system astronomy, stellar astronomy, and cosmology. We also have astrophysics classes that are taught in the physics department. If you're an honors student, please look me up in the Honors College. I teach 6 honors colloquia a year, and 4 of those revolve around astronomy, or science fiction. So I hope you've learned something tonight and you have some more questions. Don't ever stop asking questions.